Hi, everybody. It is our second video, ACT math video for the week. This one's going to kind of be like the one I did on Tuesday in that it's going to be more about me just kind of working the problem as you just kind of follow along. Let me go ahead and share my document camera though. So this problem is one problem that they have several questions that refer back to this one problem. They usually have about one of these on the test, and it's referring to this figure right here, this parallelogram. So you're going to want to copy this parallelogram down as we go through these questions. And let me just, while you're copying it down, let me go and write some things out to the side about a parallelogram, important properties that are going to help us as we answer these four questions. So and one of the most important properties is that the opposite sides, I'm just going to abbreviate that, are equal to each other. So the opposite sides would be the top is going to be equal to the bottom, AB equal to DC, and the left, AD is going to be equal to BC. Now that's in every parallelogram. The second and third have to do with the angles. So opposite angles are also equal to each other. Now, when I say opposite angles, I mean catacorner, like this ADC, this whole thing right here, which we'll add up in a minute, is going to be equal to this ABC. Then the other property is the angles that sit what I call side by side. So it would be BAD, that's actually going to be the first question they ask us about BAD. These add to 180 with this one right here, ADC. I call those just side by side. They're supplementary. Okay, and then the last property has to do with these diagonals that come across A to C and B to D. And those diagonals bisect each other. And a simple word for that is cut each other in half. So for instance, if I had from A to C was 12, when I came in and connected D to B and it crossed over here at point E, it would split it into 6 and 6. So that's what I mean by this last property. All right, let's go ahead and use this property number 3, side by side angles, add to 180, because they're asking you what is the measure, little m means measure of BAD. So they want this bigger angle right here. Well, if I add up 71 and 42, that is 113. I know that this angle over here is 113. That's from property number 2, but they want this one. So certainly you can use 360 as well to get the answer here, but I'm just going to use the 180 fact. So 180 minus 113 gives me my answer. 67 degrees. And of course, this one down here would also be 67. And like I said earlier, if you add up 113 plus 113 plus 67 plus 67, you will get 360 because any four-sided figure, the interior angles, no matter what kind it is, adds up to 360. Okay, let me scoot up just a little bit to the next question. So the next question is saying that DC, this bottom piece, is this expression, 1/3 n plus 7. And we already have an expression in the picture for A to B. So I know that those opposite sides from property number 1 are going to be equal. So we just need to set those two expressions equal. So don't assume that just because it's a multi-step problem that it's going to be difficult, because this one, as long as you know these four properties, these are very simple, 4 simple problems. Okay, I'm going to just subtract 1/3 n on both sides. That's going to give me 2 minus 1 is 1. And then let me just scoot up, sorry, so you can see this. And so then what I'm going to do is add 5 to both sides, just solving a simple equation. And of course, now I'm going to multiply by 3. What I do on the right, I have to do on the left. It's going to cancel out and turn into 3 over 3 here, which is 1. So my answer is going to be 36. So the n that would make that expression true in this case would be 36. Okay, moving on to number 37. Suppose A and C are located at 2, 10 and 30, 3, respectively, in the standard XY coordinate plane. What are the coordinates of E? Now, let me go back to the picture just for a second. You might think that if you don't have graph paper, you're not going to be able to do this problem. But remember what we talked about, one of the properties, this one right here at the bottom. Diagonals bisect each other or cut each other in half, which basically gives us the fact that E is going to be the midway or midpoint of these two, which is what they're referring to, A and C. So all I have to do is come back to the problem, and I'm going to go ahead and redraw a picture right here just so you can see what's happening. Parallelogram, just a sample parallelogram, and put 3, 30, 3 at C and 2, 10 at A. Again, this diagonal that we draw here, when we come along with DB, it's going to cut it into this is equal to this, or E is going to be the midpoint. And I don't know if we've done midpoint yet this year, but it's a super simple formula. The midpoint formula is add the X coordinates together and divide by 2, add the Y coordinates together and divide by 2. So that's going to be 2 plus 30 divide by 2, comma, 10 plus 3 divide by 2. That's a coordinate point. So that will be 32 divided by 2, 13 divided by 2. And if it's an even number like this, you're going to want to simplify it. So if you notice, here's the answer right here. An odd number over 2 doesn't have to be simplified, and most of the time they're not going to simplify it. They're not going to change it to a fraction, a decimal or a mixed number. They're going to leave it just like that. Okay, almost done. The last question is asking you which of the following triangles is congruent to ABE. So I'm going to go right here to the picture I drew. So if you notice from my picture, it's even more clear which triangles are equal. Now, it's not as clear from their picture, but in mine, I can clearly see that these are both obtuse angles, whereas these are both acute angles. So by vertical angles, these are going to be equal, and these are going to be equal, these ones that sit across. So I know that this triangle is not the same as this one or this one. So that kind of gives it away. But you can still kind of see a little bit that this one looks, from the original picture, this one looks a little bit past 90, whereas this one looks like it's just right under 90. But it tells you it's not drawn to scale, and that's what they mean by that. You can't go by the picture and think these are 4 equal triangles, because they're not. But I do know without a shadow of a doubt that this triangle, if you took and rotated it around, it would fall on the bottom. This top triangle, if you rotated it 180, it would fall on top of the bottom triangle. So this angle right here would match up with this angle right here. This angle would match up with this angle. So we're looking at ABE. It's going to be congruent to CDE. Choice K. Okay, that'll do it for this week's math videos. Please make sure that you're coming to the boot camps if you're trying to get ready for the February test or the March test. We have one January 28th, and we'll be doing a lot more of this type of stuff to reinforce your math. So hope to see you there. See you later, guys.